remember exactly, but probably late 80s, 88, I think. Before I was always working for developing the method for super resolution in optical microscopy. And first I did the inverse problem study, mathematical super resolution, and I moved to confocal and nonlinear spectroscopy to have a resolution enhancement. I was always involved with super resolution optical microscopy from my student time, but I happened to read the paper by Dieter Pohl, and I was so impressed that there is a method that makes the resolution enhancement beyond the diffraction limit. So I decided to study and join these topics. Always I was dreaming to develop an optical microscope to see molecules, to analyze molecules in a very high resolution. So we used a Raman spectroscopy. I don't remember exactly, but Japan has an industry of like watch and camera industries, and people are interested in producing small machines, small products, and like MEMS is one of the hot topics, and in the optical field we were interested in developing the method, but actually nano-optics was not much popular. People are more interested in the lithography or semiconductor applications within the nanotechnology, and it doesn't have to be optical. For me, there's no difference between 1990s and 2010. We still do many things to see molecules with an optical technology, in particular in if it is in the biomolecules in a living condition. We want to develop non-destructive, invasive imaging method. And E-beam can be done in nano, but then you have to prepare the sample, treat the sample, but then optics can make the sample to make the nano-resolution imaging without a modification of the sample. In 1980s, 1990s, I was so much excited to develop the method and to learn how other people developed the method. And everybody proposed new ideas. But by 10 years, 20 years, results are more complicated, not simple, and not much completely new method coming out. So it's not really disappointing. It's a sort of the maturing of the science, field of the science. The previous time was more exciting to me. Simplicity is the fun, more sophisticated to me. One application people do not much discuss is about the sort of nano machines. People enjoy to produce simple patterns or a feasible experiment with designed devices. But I am interested in the application of the nanotechnologies to nano machines working inside whatever the cells or the organs or even the electronic devices. It was one of the original motivation in many books in nanotechnologies. People predict or people expect in the future nanotechnology will be used, or nano-optics will be used in the many fields, but it is still to me a bit limited. including myself. So I once developed a method to fabricate nano machines by two-photon polymerization, or recently two-photon photoreduction. And the resultant machines are movable, functionalized, not much simple structures. So not only the competition in the size of or resolution, but also the functioning would be the topic, interesting topics people will think about, apply to here. So fundamental studies and applications are getting separated, and the university scientists and like an institute scientists are expected to write a very fundamental research outputs, where the industry company people do not these days attend the conferences, and they are getting more applications. So like the nano machines is not find the place for those people do together. So like MEMS, you know MEMS. MEMS have been studied a lot by university scientists and institute scientists, and they have published many papers, but it didn't become commercialized, it didn't become used by people. And this is one of the examples, because MEMS is more application-oriented rather than nano-optics. But even still, MEMS, it was not used because they were not much interested in using in a real field.